sampling distributions. First of all, the definition of population. Population is that entire group of objects which are under investigation. Sometimes it is called universe. Now the populations usually are a large group, but not necessarily. It depends upon the objective of your study. For example, if you want to study a small group of objects, the populations they can be small. The population size means that number of objects in that population, and we denote the population size with the capital N. Like we just write capital N for population size, capital N for population size. Now similarly, the sample is the part of population selected from the population. There are different methods of selecting a sample from population. We'll discuss it later, but for the time being you just need to know that the sample size is denoted with small n. So these are just the notations which you need to memorize. The small n is sample size, capital N is population size. So in population, each and every object is known as a sampling unit. So sampling unit is basically a unit which can be included in the sample. So it depends that whether on your population, sometimes the sampling units, they can be animals, sometimes they're students, sometimes they're household, or sometimes even a member of a household. Depends upon your study, the sampling unit. So if you are going to list all these sampling units, that will make up a sampling frame. Sampling frame is basically a complete list of all sampling units in the population. So in this slide you need to memorize two things. The population size is n and the sample size is small n, and then the sampling units which you are going to study, and then the sampling frame is the list of all sampling units. Here sampling is simply a procedure, because as we have discussed before that population in the last slide, population is that group which is under investigation and the size of population is capital N. And now you need to draw a sample from this larger group. So a sample, small part which have been selected from this larger part, the population, is known as is denoted by small n. So how will we select this? How will we select this smaller part from the larger part? How? So this will give you the sampling. This will give you an idea about the sampling. Sampling is that procedure which will withdraw the part of an aggregate in the belief that part will possess the same qualities. I mean, to make it representative. Same qualities mean your sample would be representative. Your sample should be representative. So your sample should represent the population, should contain about the same qualities as that of your population. So there are different techniques of sampling, which in different situations you can use different techniques of sampling, but for the time being you just focus on a random sampling. So we will discuss in this is only random sampling. So random sampling means each and every object in the population have equal chance of being included in the sample. So if that chance is equal, then it is known as a random sampling. So remember that we one thing that that the random sampling, that there are different examples of random sampling. The one is the prize bond. The prize bond in Pakistan are being selected through random sample, because everyone who holds that bond have an equal chance of winning the first prize and then winning the second prize, and so on. So prize bond draw is basically a biggest example of what is happening in random sampling. This is usually random sample have been drawn with two methods, the lottery method and the random number table method. Now you can use computer programs to draw the random samples. Usually now just moving forward, There are two different concepts in this slide, the parameters and the statistics. Parameters are the numerical values obtained from population, numerical values calculated from population, whereas statistics are the numerical values calculated from the sample. So anything calculated from the population are fixed or exact, whereas anything calculated from the sample is an estimate. So population numbers like parameters, they are fixed, they are usually unknown, and their notations are like, if we talk about population mean, it is mu, and we talk about population variance, it is sigma square, population standard deviation sigma, population proportion is capital P, and similarly the values obtained from sample, we just denote it like x bar is sample mean. Sometimes if the variable name is y, we also call y bar as mean. So it depends on the variable, like the variance is s square and the standard deviation is simply s. So these statistics are variable, I mean they change their values from sample to sample. From each sample you may obtain different result for mean and different result for variance. So parameters, they are fixed quantities, they are unknown, they cannot change their value, they are unable to change their value basically. And the statistics, they are variable quantities, they changes their values from a sample to sample. So if they are variable, we need to study their distributions also. So this is where uh, we, 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 we make use of the sampling distribution. So if it is variable, then you will study its distribution. So, and that distribution will be known as sampling distribution. Now, whenever we draw a sample from population, there are two different methods, sampling with and without replacement, remember. So if, let's say, I just want to select a sample of 3 students out of your class. So there are two methods of doing that. One is sampling with replacement and one is sampling without replacement. For example, I just choose the first student randomly and it comes out to be like, for example, Kashaf. Now, since I want to draw 3 students, so for example, the first student that I draw from your class is Kashaf. Now, before drawing the second unit, there are two possibilities here. Either I am going to replace this person back to the population, back to the class, or I will not replace it back to the population. If I'm going to replace it back to the population, then for the second selection, Kashif may again be selected. So this is known as sampling with replacement. Whereas if I'm not going to replace it back to the population before drawing the second unit, this will known as sampling without replacement. So there is a fundamental difference between sampling with and without replacement. However, sampling with and without replacement, the effect is gone if you have large populations, However, and this is sampling with and without replacement of this type of sampling. There are different type of sampling. I have already discussed with you the random sampling. However, there are broader two type of sampling, probability sampling and non-probability sampling. Basically, there are two types. Probability sampling, where each unit of the population, each sampling unit have known chance, and the non-probability sampling, where each unit have not known chance of being included in the population. So if it is a probability sampling, there are different types. One, simple random sampling, stratified, systematic, cluster, and for non-probability, there are convenience sampling, judgmental sampling, quota sampling, and snowball sampling. And this is where I have discussed already, equal chance for where each and every unit of the population have equal chance of being selected in the sample. This is what we are going to discuss. We are going to do even now. Please read this example. It is given to you like the population of size 3. Well, remember, it is a hypothetical example. Usually the population size is they are large, but this is just a hypothetical example. hypothetical example, just to establish a concept of sampling distribution here, just to establish some of the rules which we'll use in the testing of hypothesis. So a simple random sample of size 2 is to be selected. So one thing from this slide, you can see that capital N is equal to 3, and you want to draw a sample of size 2 from this population. This is the population 2, 4 and 6. And first of all, you want to find the population mean and population variance. For this, you don't need to take any sample. This is the population number. They are fixed. They are parameters. And then you will draw all possible random samples. Random samples means equal chance. All possible mean you will write all possibilities of size 2 with replacement. With replacement means that you're going to replace that unit back, so that unit may be selected again. So, and then at the last step, you will verify these two properties. Number one, the mean of all sample means is equal to the population mean, and number two, the variance of all sample means is equal to the population variance divided by the sample size. So we will just prove it in the next slides. For example, first of all, you need to know how many samples, how many total possible samples. Total possible samples mean that small n and capital N. So basically it is capital N raised to the power small n. So you have population of size 3 and you want to draw a samples of size 2. So 3 raised power 2 means there will be 9 possibilities. So how we will write those possibilities? Just see on your slides. Because you had the population of 2, 4 and 6, total number of samples, total possible number of samples of size 2 from this population are listed here. 2 can come with 2 because it is with replacement. Remember, it is with replacement. So 2 with 2 and then 2 with 4, 2 with 6. Similarly, 4 with all 3 numbers, and similarly 6 will all 3 numbers. So it is very easy to write samples, all possible samples with replacement, because all 3 numbers will be repeated with 2 once, and then all 3 numbers will be repeated with 4, and then all 3 numbers will be repeated with 6, and so on. There are total 9 possibilities, right? The second step is to take the mean of all those samples. For example, this 2 is the mean of these two numbers, 2 and 2. Then the mean of 2 and 4, and then the mean of 2 and 6. So in the second column here, the means, these are basically the mean of all samples. Now we have a column of means which is basically arithmetic mean of all possible samples. So they are 9. So if we're going to sum this, the answer is 36. And if I'm going to find the mean of all these mean of all sample means, we will write it mu of x bar. And it is basically the sum of this will come here. And since there are 9 samples, total 9 samples, look. So 36 divided by 9, the answer is 4. So 4 is basically mean of all sample means. Remember this, mean of all sample means. Similarly, we can find variance of all sample means. So for variance, you have to subtract. So like for example, this minus 2 is basically 2 minus 4. So this is basically 2 minus 4. 2 minus 4 is equal to minus 2. Similarly, 3 minus 4. 3 minus 4 is equal to 1. So this is basically x minus mu, x bar minus mu of x bar, right? The sum of this will always be 0, as we have discussed while during the lectures of central tendency, that this is the property of arithmetic mean, that the sum of the deviations, they are always 0. And then we will take the square of these deviations, like minus 2 square is equal to 4, minus 1 square is equal to 1, 0 square is equal to 0, minus 1 square is equal to 1, and so on. Then the sum of these values is 12. Just take the variance of this. Basically, this 12 is divided by the number of total samples. We will get the variance of all sample means. Now up to here, just note down that we have calculated the mean and the variance of all possible samples, of all possible sample means, of all possible sample means. And now on the other hand, we will just take the mean and variance of the population. Look, this is just the population. There is no sampling here. So the total of population is 12, and then deviation, and then the square deviations. Just the population mean is 12 over 3, 4, and then the population variance. You can easily calculate that. We have done it in descriptive statistics also. So this is mean and variance of the population. Now we just need to make a relationship here between population mean and the mean of the all possible sample means, and then the population variance and the variance of all sample means. So just carefully look at it. This is the first relationship that we can establish from the last slide, and then there is the second relationship we can establish from the last slide. Now you need to focus on these two results. These results are known as the properties of the sampling distribution of X bar. Number one property is mean of all possible sample mean is equal to the population mean. Second property is the variance of all possible sample mean is equal to the variance of the population divided by the sample size. Now these two results have been established, which we will use further in testing of hypothesis. Remember these two results. These are very important results. So we can establish the result for any population and for any sample size. Like for with replacement and for without replacement, just a slight change in these results. Now the same example without replacement. I will do sorry, just a little mistake here. Now we will do the sampling without replacement. Remember, the example number 1 is over here. The example number 1 is over here. And now we will do the same data without replacement, the same question without replacement. So first property is same. The second property, just note the difference here. This part is added due to the sampling without replacement. So in second property, there's just a little bit addition. The rest of the work is same. We just look here how we will take the samples without replacement. The same population, we use the combinations for knowing the total possible samples. So basically, there are population size is 3, and then combination 3 combination size is 2, 3C2, and solve 3C2. Basically, you can use calculators for the solutions, or we can just write 3 factorial over 2 factorial into 1 factorial. So after solving it, you can get the answer is 3. We can make these calculations by using calculators also. So there would be 3 possible samples without replacement from the same population. The population, remember, population is 2, 4, and 6. Now 2 cannot come with 2 because this is sampling without replacement. So 2 with 4, 2 with 6 are the second possibility, and then 4 with 6. The 3 possibilities are here. In the same manner as we have done before, we'll take the mean of these samples, take the mean of their mean, and then we'll take the variance of these samples, and then we will take the variance of means. Similarly, we will do the population mean and population variance. Then we will compare these two, and we will find that both properties have been verified. So if we are going to do sampling with replacement, then you can prove the two properties, as well as the same properties can be proved when you are doing sampling without replacement. So, and I have also given you some of the question in the exercise. After doing this example in the slides, you are advised to do in some of the exercises, and then let me know if there is any difficulty for you. So finally, we can extend this concept of sampling distributions to the difference between two sampling means, meaning thereby that if you have for example two populations, population 1 and then you have population 2, and you draw like population 1 you have sample size n1, and then you draw a sample of size n1 from this, and similarly then you have population of size n2. I'm writing 2 for the population 2 and 1 for population 1, and you draw a sample of size n2, and then you make all possible samples and take their means. Their means will be denoted with x1 bar and their means will be denoted with x2 bars, and then the x1 bar, x2, and then you take their differences, and then you talk about the distribution of their differences, and this is how we can write the distribution, the sampling distribution of the difference between two means. So this is just an extension of the results which we have already obtained in previous slides. The average of this difference is equal to the average of two population means, and similarly the variance, and in this case also the variance. So this is the end of the lecture.